In this video, we are going to study an experiment to study the phenomena of refraction of light through a glass slab. Through this experiment, we'll study the phenomena of refraction of light and we will calculate the refractive index of material of glass slab. In order to perform the experiment, we need a few things. These things are a glass slab, a drawing board, a plain paper, A4 size sheet I am taking, few pens and drawing materials. Now let us carry out the experiment. See, here I have placed the sheet on a board and fixed it with the pen so that the sheet may not move. Let us start the experiment by placing the glass slab on the paper. First of all, I will mark the boundary of the glass slab. Let's remove the glass slab after marking the boundary. As you can see, this is a rectangular boundary and let us name the boundary, the edges A, B, C and D. Now on the line AB, I'll take one point to be the point of incidence, along which I will consider an incident ray. Now to depict the incident ray, first of all, I need a normal. Let us mark the normal by using this protector and keeping the protector on the boundary line AB such that the baseline of the protector is coinciding the line AB. The center of the protector should coincide with the point of incidence. Now let us mark this 90 degree. Remove the protector and make the normal. Now I am going to consider the incident ray at an angle 40 degree with the normal. I will mark the angle from this side. So this 10, 20, 30, 40. This is 40 and join it with the point of incidence. This is the incident ray. Now let us keep the glass slab back. Now we'll try that the apparatus should not move. Now I'm going to take these two softboard pins and I'm going to fix the two pins on the line. While fixing the pins, we have to take care that the pins should be fixed at a distance from each other and they should be straight. The pins should be straight. Now after fixing these two pins, I will have to see the image of the pin from the other side of the glass slab and fix it and fix two more pins. I'll fix these pins by looking through the glass slab so that the images of these two pins and these another two pins should be in a single straight line. I'll bend down, see through the glass slab and fix the pins. As you can see, I have applied these two pins here on this side. I have applied these pins by closing my one eye and from this side looking through the glass slab. Let me try to show you that four of these pins, the images of these two and these two pins are in one line. Now see here from the top view we can see that these two and these two are not in one line. But when we see from the glass slab itself, if we try to focus, then the images of the previous two pins and these two pins are appearing in a same line. Now we are going to remove all these pins. I'm going to mark these pins as P3 and P4. Remove the glass slab now. Wow. These are the points P1 and P2. Now let us join these points P3 and P4 and make it connect with the boundary of the glass slab. This is our emergent ray. The ray which is coming out of the glass slab after refraction is known as emergent ray. So this is emergent ray. Now on this point of emergence, again I'll use my protector and mark the normal. Now after marking the normal, let us measure the angle of emergence. As we remember, the angle of incidence was 40 degrees. So let us see that what is the angle of emergence here. By keeping the protector this way, the baseline is coinciding with the normal. And from here I can see it is 40 degrees. The angle of emergence also is 40 degrees. Now let us connect these 2 points, the point of incidence and point of emergence, to mark the refracted ray. Now this is our refracted ray, and the angle that refracted ray is making with the normal is angle of refraction. To measure the angle of refraction, let's keep the protector on the normal and see the coinciding point. As we can see, 10, 20, 25. Now this angle of refraction is 25 degrees. Now let us calculate the value of refractive index of glass. Now let us calculate the refractive index of glass. For that we are going to use Snell's law. According to Snell's law, the refractive index of glass is given by this relation, mu Ag. Ag stands for air to glass. The light is going from air to glass. So the refractive index of glass is given by sin I upon sin R. We have calculated the values of I and R. I is angle of incidence and we have calculated it to be 40 degree. So sin I will be equal to 0.642. Same way we have calculated the angle of refraction and that was 25 degree. So sin R comes out to be 0.423. Now let us calculate the refractive index of glass and that will be equal to sin 40 degrees divided by sin 25 degree, which is further equal to 0.642 divided by 0.423, and on dividing we get the result as 1.51, which can be approximated to 1.5. So experimentally we have calculated the value of refractive index of glass, which is 1.5. Thank you.